Alright, good day students. In this video we're going to go over how to solve and simplify equations involving natural logarithms and its base e. Alright? So before we look at some examples, let's take a look at a special number called the Euler number. So write down the heading, the Euler number, the number e. Okay? The number e. The number e. This number e is also known as the Euler number. Okay, Euler is the person that came up with this symbol to represent this interesting irrational number. Okay, and he came up with a lot of results using this special number e. Okay, so some facts about the number e is as follows. E is an irrational number. Okay, E is an irrational number. Irrational number that occurs when a quantity grows continuously. Okay, remember the growth here has to be continuous. When a quantity grows continuously. All right. When we're doing problems involving continuous growth, we're going to have to make use of this symbology. Alright? So some renditions of the number e are as follows. We have e equals the limit as n goes to infinity of 1 plus 1 over n to the nth power. And this equation here illustrates the continuous growth of n here. Alright? Of the number here. Another rendition of e is using factorial symbol as 1 plus 1 over 1 factorial plus 1 over 2 factorial plus 1 over 3 factorial plus on and on. The pattern goes on. You have 1 on the top and 1, 2, 3, 4, 5, 6 on and on factorial in the denominator. Alright, another rendition for e to the x is e to the x is the inverse of natural logarithm, which is known as ln of x. Okay, so remember, anytime you want to get rid of ln of x, you're going to have to use e. If you want to get rid of e, you have to use natural log ln, your inverse. Alright? Okay, so let's look at some important formulas to keep in mind when working with equations involving a natural logarithm and its base e. Alright, write these down, important formulas. Alright, the first one is log base e of x is the same thing as natural log of x. So anytime you have log base e, just write ln. Is much more convenient instead of writing all this theory. Just use 2 letters as opposed to 1, 2, 3, 4. Alright? Another thing is e to the ln of x equals x. Now why is this the case? Because e and ln are inverses, so they cancel each other out. That's why I have x. And then also, if you have ln of e to the x, this is also x. Why is that? ln and e are inverses, so they cancel each other out and left with x. Okay? So these are important formulas I'd like you to keep in mind when working with logarithms. Alright? Alright, so let's try evaluating some expressions. Evaluate. Let's have number 1. What is it? We have e to the ln of 4. Now what is e to the ln of 4? I know that e and ln are inverses, so guess what? E and ln cancel out, and you're left with what? 4. So your answer is simply 4. Alright? Let's try another example. What if we had the natural logarithm of e to the 3x? What do you think this one is? Natural logarithm and e are inverses. So when they're next to each other, with nothing in between them, they cancel each other out, and you're left with the power, which is just 3x. Alright? Number 3. What is e to the 3 ln of x? We have this 3 that's in between these two, so they can't cancel out. So 3 times the natural log. If I want to get rid of this 3, remember the trick we did before, right? This 3 can become a power of this x right there. Alright? Natural logarithm has all the properties of the regular logarithm, only that its base is an irrational number e. Okay? So this becomes e to the natural log of x to the 3rd. Okay? Because the coefficient is also a power of the argument for natural log. I see e and ln are next to each other, so they cancel out. This and this cancel out, and you're left with x to the 3rd. Alright? Let's try another example, number 4. What is 2 times the natural log of e to the quantity 2x minus 1? There are 2 ways we can do this. We can first of all cancel or get rid of this 2. Okay? But we're going to get exactly the same answer. So since ln and e are next to each other, I can just cancel them since they're inverse operations. So this and this can cancel out. And then we're going to have 2 times 2x minus 1. Final answer is 4x minus 2. Okay? Now if I wanted to do it the other way, let's say I wanted to do it a different way. Let me show you how that will work. I'm using method 2. Let's call this M1. Method 1. If I want to do it another way, I would have just said, okay, I have 2 ln of e to the 2x minus 1. So I want this 2 to come to this power right here. That power. Okay? But when 2 comes to this power, there's already a 2x minus 1 there. So what happened? That 2 gets multiplied by the 2x minus 1. So we have natural log of e, and then you multiply the 2 times 4x minus 2. Like that. Alright? ln and e are inverses, so they cancel out, and you're left with the answer we got before, which is 4x minus 2. So whichever method you want to use, it's fine. Just remember that the coefficient can always be multiplied by the power. Alright? Okay, so that's for the first part of the notes. Now we're going to try out some crossword problems. Alright, welcome back, students. Now we're going to do some more notes on solving natural logarithmic equations. So write this down. Notes 2. Solving natural logarithmic equations. Okay, so in this one, we're going to learn how to use that inverse of the logarithm to basically eliminate logarithms, or to use logarithms to eliminate its inverse, which is e. So, solve. Okay. Number 1, what would we have? E to the x equals 3. Now, how do we solve this? What is the opposite of e? The opposite of e is natural logarithm. So to get rid of this e, we're going to take the natural logarithm of both sides. So on the left side, we're going to take the natural logarithm, not multiply, we're taking, okay, take the natural logarithm of e to the x equals the natural logarithm of 3. Okay? On the left side, the goal is it gets rid of the e, because these are inverses, so these two cancel out. So you're going to have x equals the natural logarithm of 3. Alright? And there goes your answer. Alright, let's try another example. What if we had number 2? What if we had 3e to the x minus 4 equals 2? In order for me to get rid of the I need to get it isolated first. I need to get it clean, and then I can get rid of it. Okay, so to get rid of the e to the x, I need to get rid of this 4 first, and then the 3, and then I can get rid of the e. Alright, start from the outside to the inside part. Reverse PEMDAS. So let's get rid of the 4 first. How do we do that? Use this inverse, add 4 to both sides. And then that yields 3e to the x equals 6. Next item to eliminate is the 3. So divide both sides by 3. That yields e to the x equals 2. Alright, now, what is the inverse of e? The inverse of e is natural log, so you take the natural logarithm of both sides. Take the natural logarithm of e to the x, and on the left side and on the right side, you take the natural logarithm of 2. Okay? So ln and e are inverses, so they cancel out. This and this cancel out. So you're going to have x equals the natural logarithm of 2. Alright? So there goes your answer. Okay, let's try another example. Let's do number 3. What if we had the equation, the natural logarithm of x plus 3 is less than 5. Okay? Write that down. Now in this case, we want to get rid of the natural logarithm. So the opposite of natural logarithm, we need to take the exponent of it, is its base. So what is the base of natural logarithm? Well, guess what? The natural logarithm, its base is e, right? So you can put a little e here. That's okay. So what we're going to do is, that's the basis of exponentiation. So we're going to put a big E on the left side and a big E on the right side. The inequality is less than. And these two things will be exponentiated. Okay, so you have a little ln of x plus 3 and then a little 5. Okay, you don't have to put the E there. That's not necessary, it's invisible. That's what you have. So since these are opposites, inverses, you know what happens? They cancel out. So this one and the ln cancel out. And on the left side you have x plus 3 is less than e to the 5th. Try to get x by itself, you subtract 3 from both sides. And then you have x is less than e to the 5th minus 3. And there goes your final answer. Okay? There you have it. Alright, so that's that for the second part of the notes. We're going to continue with the class one. Alright?